First question is in plain English, if you can explain what is the Kubernetes architecture and the components and how do they work?
I will try to talk at a very general level because I don't really know what's the background of the people here. Like might be people who don't have previous exposure to the architecture, and also like digress a bit to like different Kubernetes distributions, which might be interesting for more experienced people. So about Kubernetes architecture, there's many Kubernetes distributions, and they don't necessarily have completely the same architecture. So to be a CNF certified Kubernetes distribution, your Kubernetes API needs to pass a set of automated tests. So in a way, you can think of Kubernetes even as a set of as an API specification. In theory, I think it would be possible for somebody to come up with a Kubernetes distribution that has a really weird blockchain-based architecture or something like that. But in practice, we don't really see it. I think most of the Kubernetes distributions go in very similar directions and have very similar architectures. If any of you have found out some really weird Kubernetes architectures, feel free to post it in the chat. All right, next slide, please. So at the 10,000 feet level, we can split the Kubernetes architecture into control plane and worker nodes. So control plane is the part that is responsible for running the Kubernetes itself and coordinating it. So and this control plane itself is composed of various components like API server and a cluster data storage and so on. And worker nodes are the part of the cluster that actually runs the stuff you put into Kubernetes, your workloads. So it could be bare metal servers or virtual machines or your laptop or like serverless Fargate virtual machines or whatever. It doesn't matter as long as it can run stuff. And each node also has various components that make it possible for this node to work as part of Kubernetes. So here we have a diagram by Lucas. Thank you, Lucas, for giving this for me to use. And if you look at the center of this architecture, you can see there's the API server, and all the other components only talk to the server. So none of the components talk to each other directly. And if you look at the user also only communicates with the API server. Maybe they are using a command line tool like kubectl, or they are using some graphical user interface. It doesn't matter. Like in practice, the user is only communicating with Kubernetes through API server. And that's why you don't really need to understand the architecture necessarily to use Kubernetes. You can just treat it as a black box that does what you want, and you will get along pretty well. To understand how Kubernetes does, can you go back?
Oh, sure, sorry.
Yeah. We can think of like an example of a case of somebody using Kubernetes to, let's say, running 3 containers that run Nginx web server. The user sends the configuration that specifies that you want to run 3 Nginx containers to API server. And controller manager that is looking at what is happening through the API server sees this. It takes this resource and it transforms it to a set of pods to run in Kubernetes. Pods are like the basic unit of workloads in Kubernetes. And these pods, along with the configuration that the user sent before, to the API server is stored in this etcd, which is the default key value store for storing Kubernetes cluster state. And when these pods appear, the scheduler there on the right sees it, that is through this API server, and it defines which pods should run in which nodes. And it again sends this information through API server. And then finally, these pods are scheduled to run in the nodes themselves. And the nodes again get the information through API server. This is like a very high level explanation of how Kubernetes does what it does. I hope it's helpful to somebody.
It's quite high level, yeah. Very big picture.
All right, next slide, please, Alex. So Anoop challenged me to explain also architecture of K3S and K0S, which was very nice. I wasn't very familiar with these projects, so I researched them a bit and look at their architecture just to find out how it's different from, let's say, vanilla Kubernetes, which I was explaining before. If you look at this K3S architecture, it's not very different. One difference is that their default data store, instead of etcd, it's SQLite. And there's a tunnel proxy for communicating between agent and the server, which is basically the same thing as the worker node and control plane we were talking about before. One interesting difference is that there is each of these only runs in a single process. So you see there's this dotted line that says process. And that means that in this K3S agent, all of these components like kubeproxy and kubelet and whatever, they are running in the same process. And this is a way that K3S saves memory. So the K3S is basically a small memory footprint simplified Kubernetes distribution originally created by Rancher. It's for running Kubernetes in Internet of Things and the cloud. And this is like the architectural method by which they make it possible to run it with a smaller memory footprint. Next, please. All right, K0S is another Kubernetes distribution. It is in a way similar to K3S, but where the goal of K3S is to be small and light for Internet of Things and the edge. What K0S is all about is about, let's say, in my perception, it's about ease of installation. So it's all packaged in one single binary. As you can see here on the right, where is the K0S.bin and all the various components that we were looking at before, and some that are different or named differently are contained in the single binary.
And Jukka, sorry to interrupt you, but one thing that Lucas just dropped in the chat, and I think it's worth mentioning, going back to the K3S, it's that now it's a CNCF project as well. So even though you mentioned it was originally developed by the Rancher Lab guys, it has matured enough to be promoted to the CNCF.
Yes, indeed. All right, you can go forward. And next one. Yeah, here is the control plane in K0S architecture. And here you can see it's like there's again this one single binary that you need to kick off a Kubernetes control plane in your server or virtual machine or whatever, with all of these different components running there. Can you go next one?
Sure.
And the same one with worker nodes. Again, you start a single binary which takes care of running all of the components that you need for a Kubernetes worker node. And this is the end of my answer, and I'm now eager to hear further comments from my fellow panel participants or from the audience.
Well, there's already one question. What is the K0S API, and does it have its own server, or how does it work?
I think it's just this is again from the perspective of someone who hasn't gone really in depth into this K0S, but it's I think it's just the same Kubernetes API, and maybe they have implemented some of the API functionality on their own. Maybe they haven't, but I would be surprised if it was different than the regular Kubernetes API, just packaged into the same binary
And
for K0s.
Sorry, Anoop, have you been using this K0s since it was your challenge for Jukka?
No, I have never been using it.
All right. Yeah, I guess it's still a fairly new project. Like it's one of those ideas that sound very, very promising, but it's still like starting to get adopted. So it's very kind of a niche technology, you know, like there's not that much people who have been using it.